What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back at it with digital SAT content. And what we're doing is we're doing a nice digital SAT from one of my newest partners, the SAT Crash Course. What's up? Sorry, just doing a sound check. So yeah, here we go, SAT Crash Course. Now, I know in the description I put that we're doing digital SAT practice test 2. We're actually going to be doing digital practice test SAT test 18. But whatever, we'll be doing digital test 2 probably next week or the week after. So all good. All right. A couple things I want to say off the bat. Hey, what's up, Yusuf? So here's the thing. Number one, this is an amazing company. These are amazing practice tests. So if you are prepping for the digital SAT, I would definitely recommend them. You can sign up and purchase these digital practice tests with the link in the description below, okay? And if you use the code SCALAR, that's SCALAR, all caps, like this, like the channel name, you're going to get a 20% discount. I know it was formerly 10%, but now they've changed it to 20%. And again, look, I'm going to say it one more time. I choose my partners very carefully. These guys have done their due diligence. They put together amazing tests on an amazing platform, so I highly recommend it, and that's all I'll say about that. All right, so without further ado, let's do this thing. I'm taking this test for the first time in real time. That's always part of the fun, and we're going to see how we do. Had my blood drawn today, got a little dizzy, but I'm actually feeling a lot better now, and let's hope it doesn't impact my performance. And that's that. Here we go. So we're going to skip through the reading, okay, or the English parts. Boom, boom, boom. We're going to go straight into the math. Okay. Next. Oh, wait. Skip this as well. Okay, here we go. Time for the math. All right, drink a little more coffee. Are the PSAT scholarships only available for American citizens? I don't think so, because possibly for maybe the ones that are awarded, what was it? Is that through the College Board or whatnot? Like, there might be some, sure. But then there's also individual scholarships that can be awarded based on the National Merit Scholarship that can be from companies or schools. I imagine those are probably more open in terms of who they can take. So, but that's my guess. I'm not positive. All right, ladies and gentlemen, let's do this thing. We're going to start in, and here's my little whiteboard so we can do scratch work. 3, 2, 1, let's go. And you know how I love taking new tests. Here we go. Boat sailing, constant speed along straight line C. Equation D equals 12T is distance, nautical miles. How many nautical miles will have 5 hours? So plug and chug. 5 times 12 is 60. B is the winner. Boom, done. Next. Line of the XY plane is the x-intercept. Okay, so immediately when I see stuff like this, I'm going to be like, oh, x-intercept. Oops, too thick. Hold on. I'll say x-intercept. Oh, that means 4, 0, right? Where y is 0. Y-intercept of 2, that's 0, 2. Which equation represents this line? So I see these both have y-intercepts of 2. These have y-intercepts of 4. So C and D, I'm going to eliminate real quick. Hold on. Boom and boom. Okay, now it's one of these two. And, you know, what we can do quickly, since I know 4, 0 is a coordinate, I can plug in 4 and see, do I get 0? Yep, negative 1/2 times 4 is 2. Negative 2 plus 2 is 0. This one is wrong, so A is the winner. We'll eliminate B as well, not that we need to. Let me just double check now. 4, 0, 0, 2. Boom, done. Okay, next one. All right, 2x over w equals 10. What is the value of 2w over x? Okay, so how should I do this? Let's multiply both sides by w. We get 2x equals 10w. And let's divide by x, I guess. Wait, yeah, divide by x. And then we're going to have 2 equals 10w over x. And then I want 2w, not 10w. So if I divide both sides by 5, then you get 2w, and that's equal to 2/5. Okay, let me just make sure I didn't make any mistakes. So that's 2/5, so 2x. So you're basically, it's 2 times, we could say like 5 over 1, that's 1 over 5, 2/5. Yeah, okay, boom. So I just checked it mentally like that. I imagined x being 5, w being 1. That's one possibility. So then here you'd flip them, so it'd be 1 on top, 5 on the bottom, 2/5, boom, done. Triangles, okay. Triangles X, Y, Z, and L, M, N. X, Y, Z, L, M, N are congruent, where X corresponds to L. The sum of the measures of y and z is 135. So those two add up to 135. That means these two add up to 135 as well because they're congruent. So then n and m, so what's the measure of angle L? All the angles add up to 180. So 135 subtracted from 180 is 45. Boom, done. Which expression is equivalent to it? Okay, so we're multiplying two of these monomial, or these, two of these expressions. And so what we're doing is we're adding the exponents. So negative 2 plus 5 is 3, and then it's y to the 3 plus negative 2 is 1, and then z to the 4 plus negative 3 is 1. And that's how you do it. For these answers are just going to have nothing in front of the y and z because it's the same as to the first power. So B is the winner. Boom, done. Let me make sure I didn't make a mistake. X cubed. Yeah. Y to the 5th. Yep, didn't miss anything. All right, 6. Ooh, box and whisker. Box. Here, let me go like this. Let's pop it over here. And then it says the box plus number is blah, 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 blah. Which statement was true? Okay. Median of C is greater than D. So the median, yes, that's true. Because the median is that middle line. The median of C is less than D, false. The range is greater in C than D. 30 to 50, that's 20. I know these are wrong, right? I already know it's A, but still. And then this is 25 to 45. So both of them are, 25 to 45. So they're both 20. 20 and 20. So that's wrong. And the range of scores, so the ranges are equal. So that's it. Oops. Wait, did I skip one? Uh-oh. What did I do? Oh, yeah. I accidentally skipped 7. All right, what is the x-coordinate of the point of intersection? Okay. Point of intersection is where these two are equal to each other. So let's set them equal to each other by a little substitution. 3x minus 5 equals rad x plus 3 square both. You could also plug and chug and see which one gives you the same value for both. Square both sides, that's going to give us, right, if you FOIL this, it's going to give you 9x squared minus 15 minus 15 minus 30x, and then negative 5 times negative 5 is 25 equals x plus 3. Ooh, this is going to be not so pretty. And then we're going to minus x, so 9x squared minus 31x, and then minus 3 plus 22 equals, wait. You know what? I should just do this in Desmos. Here, they want to know the point of intersection. Let's just graph it. 3x minus 5 and square root of x plus 3. And it's right there. It's 2.444, which is probably this one. But let's check it out. What was it, 22 over 9? Yep. Boom. So there's how you can use Desmos. That's pretty nifty. But anyways, if I wanted to solve this, I guess it might be factorable, but it just seems like a lot. So we're going to move on. Boom, done. Okay, random sample of people were surveyed to determine the proportion of people who prefer cats as pets. The estimated proportion of cat lovers is 0.38 with an associated margin of 0.05. That means it goes down by that much and up by that much, right? So 0.33 and 0.43. Based on which volume most appropriately conclude. Okay, so it means that the proportion of cat lovers is between 0.33 and 0.43 is probably what it is. It's not exact. Wrong. No, probably not plausible that it's less than that. It's probably in between. It's boom. There it is. Margin of error. Very nice. Let me just see. Yeah. Okay, we're good. 9. How many points do these intersect? I mean, again, I can just graph these, but it's 4x plus 2. It's going to be 2 points. It's got to be 2 points, but we'll graph them on Desmos. X squared. And then we have, what is that, 4x plus 2, right? And there it is. 1 and 2. That's it. All right, number 10. The linear function h has a slope. Okay, hold on. Linear function. Let me get some of this. I couldn't drink any caffeine this morning because of the blood test, so... All right, linear function h has a slope of -2 and a y-intercept of 7. Which equation shows that? That's what it should be. Slope of -2, y-intercept of 7. That's it. A is the winner. Let me just make sure I didn't make a mistake. Yep, we're good to go. Boom, done. 11. Boom, boom, boom. What is n? Okay, so we got 2 equations. Let's see if we can solve this. So for this one, maybe we can do a little substitution. So for this one, I'll multiply both sides by 2. 5x equals 2y. And let's see, what should I sub? Yeah, I'll sub for y. So then I'll say divide by 2, y equals, we'll say 2.5x, okay? And then let's plug it in here. So we got 18 times 2.5x over nx is equal to 15. The x's are going to cancel. 18 times 2.5, that's 36 plus 9 is 45. So 45 over n equals 15. N is 3. Boom. Okay. Now let's make sure that's right so that you plug it in 3 there. And you get 15y over x is 15. Oh, yeah. Again, let's use those substitution things that we tried, right? So if this is going to be 2, let's say x is 2, y is 5. That would give us 2, right? 10 over 5. So 2 and 5. So that would be 2 times 3 is 6, and 5, which is 90. 90 over 6 is 15. Boom, verified, done. 12. Function P models the number of plants in the garden. How many plants are being eaten by the pests each day? That's the slope. They're losing 3 per day. Just making sure. Okay, yep, 3. Very interesting. Wait, let me just make sure I didn't misread this. P models the number of plants in a garden T days after a certain pest starts to eat them. Yeah, so they're starting with 1,200, then the next day there's 1,197. Okay. Company's revenue increases by 5,000 every month. That is linear. If it's just straight up 5,000 every month, it's straight up linear. Company's revenue increases by 5,000 every month, right? If it said like by 500% or this and that, like that'd be different. Okay. Hi, I see the comment. Yeah, visit New York. I live in LA, so that's a bit of a trek, but New York is a great city. All right, determine the solution for the given system of equations. What is the value of y? So again, I can plot these and just look for the intersection, but I'm going to do it old school just for fun because I like doing elimination. So we're solving for y, so I'm going to eliminate the x's and multiply the top one by -2. We get negative 8x plus 6y equals negative 24. The bottom, we get positive 8x plus y equals 52. Add them together. Goodbye. 7y equals 52 minus 24 is 32 minus 4 is 28. Divide both by 7 and we get y equals 4. 4 is the winner, but let's double check. So if y is 4, x would have to be 6 because 48 plus 4 is 52. So 4 and 6, 24 minus 8. Wait. Oh, I'm sorry. 4 and 6. 24 minus 12 is 12. Okay, double verified, done. 15, the equation above relates variables x and y. Which value of x does y reach its minimum? What are they talking about? They are talking about the vertex, and this is a positive leading coefficient, so we know it's going up like that. So where is the vertex? What is the x value of the vertex? It's negative b over 2a. Negative b is negative 16, which is 16 over 2a. 2 times 4 is 8, and that gives us an x value of 2. And that is it. You can also graph this and find the minimum, aka the vertex, okay? 16, the function k is defined by blah, blah, blah. Graph of this has an x-intercept at f is 0 and a y-intercept at 0g. Hold on. So that means, let's get my head around this. So I know what the y-intercept is. The y-intercept is 10. So g equals 10. And I can figure out what the x-intercept is when this equals 0. So that would be when x is 5, right? That's going to zero out the function value. So f is equal to 5. I know that. What is the value of g minus f? 10 minus 5 is 5. C is the winner. Done. Let me just make sure I didn't make a mistake. Y-intercept minus the x-intercept. Y-intercept is 10. X-intercept must be 5. Yeah, that's right. The radius of a circle. Let's draw this out. Hold on. Radius of a circle. Oh, it's 2 circles. Hold on. Okay. So radius of circle A, which is the big one, is 50 times the radius of circle B. So we can say x and 50x. The area of circle A is n times A. Okay. So there's a little shortcut here. We're talking about relative length values, and we see one is 50 times the other. If we're trying to get the equivalent area relationship, it's whatever the length relationship is, which is 1 to 50, and then you just square both of them, and that's what it will be. So it's going to be 1 to 2,500. So the value of n, since it's that times circle B, right? So whatever circle B is, if it's 1, 2,500 times that. So n is 2,500. Now, if that didn't make sense, the other way you can do it So you can choose values. You can be like, hey, a radius of 1, hey, a radius of 50. What's the area of that? Pi r squared, which is just pi. And what about the other one? Pi 50 squared. Again, 2500 pi versus pi. 2500 is n. Boom, done. Okay. Let me take a screenshot of this graph. Wait, why? Let's see if I can get it all in there. All right, here we go. We got that, and let's see. Describe the best y. What is the approximate y-intercept of the line of best fit? Okay, so we don't know the y-intercept because we only have this much information. But what I like to do in these cases is I like to choose two nice points, right? Here we got 22, 30. And then we got, oh, look at this. We got another really nice point, 24, 32, okay? So we got 24, 32. And now we can come up with an equation for the line. What were they asking? Y-intercept, right? So subtract down 30 minus 32 is negative 2. 22 minus 24 is negative 2. Wait, is the slope of 1? I guess it's almost the slope of 1. All right, it's an approximation. And then use point slope. Then we got y minus, let's use the top coordinate, 30 equals 1 times x minus 22. And now to get the y-intercept, I'm just going to add 30 to both sides. Y equals x minus 22 plus 30 is 8. So it should be approximately 8. So I'm guessing it's 9.4. Okay, let me do a better point selection because that feels a little rough. Because I shouldn't have chosen them so close together. And I think that's the issue. Actually, let me not erase all this. Let's just make a little room. Okay, so usually, which I should have done here, pick points farther apart. Those points just look so nice, but let's see, 10. Let's make that 10 and 14. And then maybe up here looks like 28, 28 and 30. Let's round up to 36. Okay, so we got 14 minus 36 is negative 22, right? Over 10 minus 28 is negative 18. So it's a little bit more than 1. It's like, what is that? 11 ninths. So then, and now using point slope, y minus 14 equals 11 ninths times x minus 10, okay? And then we go 11 ninths times negative 10 plus 14. That's going to give us the y-intercept. So let's do that in the calculator. We got, and that's just me putting it back in a slope-intercept form. So 11 ninths times negative 10 plus 14. Oh, that's not right. It can't be right. 11 ninths x minus. Oh, what the heck? I got such a different answer that time. Wait, that can't be right. Hold on. Negative 22 over negative 18, that's 11 ninths. And then we do y minus 14. Hold on. Something's weird here. No, it's right. 11, hold on, 10. I did 10. So this is tripping me up. Oh, what am I doing? I'm so bad. That's 10, 19. Jeez. Okay. Well, there you go. Caught my mistake. So it's 10, 19, excuse me. So then it's 19 minus 36, which is negative 17. There we go. And then over here, I think we still have the right point, right? 22. Oh, no, I did. What did I do? 28, 36, approximately. So negative 17 over negative 18. There we go. So that's just 17 over 18. So then it's 17 over 18 times negative 10, and then we're adding 14. Okay, so so it's good we rechecked it because it's much closer to 4.7. There you go, lesson learned, right? Choose those points that are farther away. That was a bad approximation, what I just did. So, yep. All right, number 19. Measure of angle x. Let's write this out. Measure of angle x is 5 pi over 6 radians. Measure of angle y is 11 pi over 18 radians. Greater than the measure of angle x. Wait, hold on. Measure of angle y. So it's this plus this. This is, okay, 6. And then we can make it 15 pi over 18. Multiply top and bottom by 3. Add them together. We get 26 pi over 18. What is the measure of y, which this is y, in degrees. So to convert to degrees, you multiply by 180 over pi. So this cancels out to 10 and 1. Those go away. 10 times 26 is 260. That's how you do it. Done. Where is it? 260. A biologist measures 10,000 algae cells after 8 hours. Okay, hold on. After 8 hours, 10,000. After 8 hours, that's 40,000. So it's quadrupled in 8 hours. Okay. Oh, and this is a doubling thing. So it probably doubled in 4 hours because it doubled in 4 hours to 20 and then doubled again in another 4 hours to 40. All right. And the reason why I bring that up is because it's C, which is my initial value, which is 10,000 times 2, which is the, it doubles at how much. And then R and T are constants, and P is the number of algae cells T hours after the initial. What is the value of R? Oh, I know what this is. This is, hold on, let me think about this for a second, because it's like a half-life formula, but to me, if you're putting in the number of, it's 1 over 4. It's 1 over 4. Let me show you why. So here would be my formula. It'd be T over 4 hours, okay? Because you put that half-life down here. And you'll see it makes sense with the values we have. When you plug in 0, you get 10,000. When you plug in 1, you get, not 1. You plug in 4, that's 4 hours. 4 divided by 4 is 1. 2 to the 1 is 2 times 10,000 is 20,000. You plug in 8, that goes to 8 over 4, which is 2. 2 squared is 4. 4 times that is 40,000. So it works. And so what is multiplying T? It's being divided by 4, multiplied by 1/4. So B is the winner. Done. Okay. 2 left. What is the solution to the given equation? Again, I can graph this in Desmos. But what I'm going to do is I'm going to square both sides. I'm going to do it algebraically. Then I'll show you in Desmos. 9 minus 2x. Then we're going to add 2x to this side, 6x, add 15 to that side. That equals 24. X equals 4. And that's it. We just got to make sure it's not extraneous. 16 minus 15 is 1. Square root of 1 is 1. 9 minus 8 is 1. Square root of 1 is 1. 4 is the winner. Done. Last one. Which of the following are solutions to the given equation? Okay. When in doubt, just simplify. All right. Oh, actually, wait. No, there's nothing to simplify. Because these are the same. Hold on. Wait. I think. Can I shortcut this? Wait. If those are the same, x minus c has to equal 1. That's it. You see? Because otherwise these two wouldn't be equal to each other. So well, that's weird. You see that? Because I would imagine x would need to equal c plus 1. Not 5. Because if it's c, then that's 0 equals x squared minus 25. Oh, but that could work. Because, okay, hold on. Let me think about this for a second. So if x is c, then that does work. Look, because you get c. No, it doesn't. C squared minus 25 equals 0. But then c could be. Oh, but then c's. Oh, I get it. This is a crazy question. Okay, look. So x can't be c because then we'd have 0 on this side. And no, wait. But then c is greater than 5. So if x is equal to c, we'd get 0 on this side, right? And then x is equal to c, whatever that is, it'd be c squared minus 25. But c has to be greater than 5, so there's no way this would 0 out. So 2 is not possible. Anything with 2 is not possible. So it's either 3 or 1 and 3. Well, 3 definitely has to be true then, so we don't even need to worry about 5. So it's 3 or 1 and 3. So -5. So let's see. Let me think about this for a second. Why is this question tripping me out so much? So if that's -5, if x is -5, we'd get 0 on the left side. If x is -5 here, we'd get 0 on this side. 0 times it, yeah. So 3 works and 1 work, right? Because we get 0 equals 0. So 3 and 1 should work. Okay, let me just think about that for a second. if I put a 5 in there for C. No, if I put a 6 in there for C. Let's plug and chug. Let's just imagine this before we got plenty of time. So if I put a 6 in for C, x squared minus 25 equals x minus 6. And then x squared minus 25. So obviously we know 5 and negative 5 work because they just zero out everything, right? And then the question is C. Now, if in this case, x would equal 6, right? So it'd be 0 on this side, C, and then on this side it'd be 36. Yeah, so C doesn't work. Okay, I feel pretty good about that. Let's move on to section 2. Going right into it. Okay, let's go. Which points give 3 values of x and a corresponding value of y for the given equation? Okay, let's see. So 0, 5, yes. Okay, they all have 0, 5. 1, 3, yes, because you plug in 1, you get 3. Negative 2 plus 5 is 3. And then 2, it's A. I'm just going to move on because module 2 is way harder, and we need our time. So I'm going to have to hustle. Okay. So we got this diagram. Let's take a picture. And that's T, so whatever. S and line are parallel, units is the value of y. Okay, so these are parallel. These are alternate. No, what am I saying? They're not alternate interior. This is 130. These are sup, so this is going to be 50 because they add up to 80. These are alternate interior, which means they're equal, which means y is 50. Boom, done. A store increases the price of a shirt by 10%. The original price of the shirt was Y. What is it? Okay, so to increase by 10%, this would be taking 10% of it. Increase by 10% is 1.1 times Y, all right? The other way would be Y plus 0.1 Y, but they didn't have that option. Okay, next. Function is defined, but this was a value, for value of X is 9. Okay, so plug in 9 here. Here, let's write it out. Oops. Plug in 9 for f of X. And set it equal to that and solve for x, right? So minus 5 from both sides, 4 equals 1/4 x. Multiply both sides by 4, x equals 16. C is the winner, done. Okay, let's just make sure. Plug in 16. 16 times 1/4 is 4, plus 5 is 9. Boom, done. The function, blah, 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 what's the value of g of 4? Plug and chug. So point here, let's use a calculator. So this becomes, can't see it. 0.5 to the 4. That when it says g of 4, that means 4 replaces the x. So it's 0.5 to the 4th power, and then it's that value times 150. And there it is, 9.375. Boom. Next. Okay, right triangle. We got to draw a triangle out. So let's do that now. And then, oops. We got to make it, let's make it thicker so you can see it better. Okay. And it says F is the right angle and DEF. Okay, there we go. It says sine of D is 3/5. So sine is opposite over hypotenuse. So we can just say 3 over 5. We could also say 3x and 5x, whatever, but it doesn't matter. And then it wants cosine of E. E is right here. Cosine of E is adjacent over hypotenuse, which is also 3/5. By the way, this uses that rule that sine of an angle is equal to cosine of the complement. So you could have shortcutted this without a diagram if you wanted to, known it's 3/5, but anyways, boom. 7. Function H is defined by this. Y-intercept of the graph is, what is the y-intercept? All right, y-intercept plug into 0 for x. 5 to the 0th is 1 times negative 4 is negative 4 plus 20 is 16. 16 is the winner. Boom, done. You could graph it as well if you wanted to. Which expression is equivalent to this? All right, let's see. Okay, let's go old school with it. We're going to factor the bottom here, and we got x minus 3, x plus 3. And then this one we're going to factor minus 2 over, and that's x plus 3, and that's a perfect square. X plus 3 times x plus 3. And now we're going to get common denominators, which is what they did. So we need another, and you know what I'm going to do? I'm going to make it x plus 3 squared because that's what they have down here. And then I need a common denominator, so I need to square this one, meaning multiply by x plus 3 over x plus 3. And for this one, we need to get x minus 3 to get nice common denominators. Okay, distribute. So that's 5x plus 15. Don't forget that minus distributes as well. Minus 2x, and then minus negative 6, which is plus 6. That combines to 21. That combines to 3x. So it's 3x plus 21 on top, which is a over x minus 3 times x plus 3 squared. A is the winner. Done. The function blah, blah, blah is that next y plane graph of is the result of translating this to the right by 3 units. What is the value of Q4? What's the best way to do this? So what you could do is plug in 4 here and then shift it to the right by 3. I think that should be fine. But we're going to double check because I'm also going to plug it into Desmos just to make sure. So Q of 4. So P of 4 is 3 times 6, right? I'm plugging in 4. 4 minus 1 is 3. 4 plus 2 is 6. 3 times 6 is 18. Times negative 3 is negative 54. No, that doesn't make sense. What am I saying? What you have to do here is, I did that wrong. What you have to do here is, if this is translated 3 units to the right, if you're plugging in 4, hold on, let me just think about this for a second. I'm trying to see if I can shortcut it. So we have a function, let's say like this, and then you're translating it 3 units to the right, and then they want Q of, let's say here is 4. And that would be, that'd be the same as plugging in 1, right? Like back here. Because we translated it 3 units to the right. So you go 1, 2, 3, right? And so whatever you plugged in as 1 for that original equation, that's going to be like plugging in 4. So I think that's right. Never mind. So we can plug in 1. So it should be 0. Okay. We're going to, you know what? Let me flag this one because I don't want to spend a crazy amount of time and then run out of time later. But we'll check it in a bit. Actually, no, let's do it right now. Let's get it over with. Okay, so we got I'm gonna show you how to graph it. So we got x Okay, so there's the graph, and as I said, I think we want that value. But if I'm gonna translate it 3 units to the right, here I'll show you a quick shortcut to do that. So you basically, oops. Darn it, didn't work. I'm trying to copy it. Oh, it doesn't work. Okay. X minus 1, x plus 2, x minus 7. And to translate to the right by 3. What was it? By 3, right? Yeah, so what you do is you basically like minus every x value by 3. So technically if I do this should do it. Yeah. And now you can see, right? It's literally been translated 3 units to the right. So actually, this is great. And then we want 4, and there it is. It's confirmed. 4, 0, boom, done. Okay. 10. Cylinder has a volume of whatever, 160. And that's equal to pi r squared times h. And the height is 10, so we're going to replace h with 10. And then it says, what is the lateral area? Yowzers, lateral area. Okay. Well, so here's the deal, right? If we have a cylinder, the lateral area is all of this, okay? Which the formula for that is 2 pi r, which is the circumference, times the height, okay? Which is 10. So it's 20 pi r, but I need to know what the radius is. I can get that here, I think, because pi's cancel out. Divide by 10, 16 equals r squared, r equals 4. So it's 80 pi. Whoa, oh, there it is, B. B is the winner. Ah, it's an interesting one. Lateral area. Okay, for the function g, the value of g doubles for every increase in the value of x by 2. Hold on. Ugh, I don't like that. So the function doubles. Oh, I know how to write this. Doubles for every. Okay, so every time x goes up by 2, it doubles, meaning it's going to be x over 2. So for example, it's at 0, it's just itself. Then it goes up to 2, then it's 2 to the 1. Doubles once. Then it's 4, increasing by 2. 4 over 2 is 2. 2 squared is 4. Now it's quadrupled, so doubling again. And did it say initial value? Yeah, initial value of 10. So this is just a straight up exponential. That's A. Let me just make sure I didn't make any mistakes. 2. Yeah, it's doubling. Yeah, it's G. Doubles for every increase in the value of x by 2. Yep. Boom. 12. Which is the following sets of ordered pairs for all values of x and the corresponding values of y solution to the given inequality. Oh, these are so annoying. Okay. Oh, you know what I can do with the calculator? This will be pretty slick. So let's actually graph this inequality. Usually what I do is I just go plug and chug. Hey, do they satisfy all of them? So here's what, this might be easier. 3x minus y is greater than 6, okay? And we can just see which one of these solutions don't kind of fit in the shaded area. So 4, 6. Oh, it's right on the line. I think that one's out because look, yeah, if you plug in 4 and 6, that's 12 minus 6. 6 is not greater than 6. So that one is out. Nothing else with 4, 6. Okay, that doesn't help. You know what? I'm just going to plug in. I think it's going to be faster. Okay, 4, 4. So that's 12 minus 4 is 8. 15 minus 8 is 7. Yes. 18 minus 12 is 6. This one's out. 6 does not equal 6. 12 minus 8 is 4. That's out. That is not greater than 6. And then, okay, 4, 0. Oh, let me write it here. It's probably D, I'm guessing. 4, 0, 5, 3. But I have made mistakes on these in the past. So you have to be really careful. So yeah, let's just select it for now. Okay, 4, 0. 12 minus 0 is 12. That's greater than 6. 15 minus 3 is 12. That's greater than 6. 18 minus 6 is 12. That's greater than 6. Yep, D is the winner. Boom, done. Which is following our factors. Okay, let's factor. So let's first factor out of 4. And we got x squared minus 2x minus 15. And then we can factor it more. X minus 3, or wait. That would be x minus 5, x plus 3. Because it's what two numbers multiplied negative 15 add to negative 2. 2x minus 10 is a factor. Because if I take a 2, I can distribute a 2 back in. And I can make it 2x minus 10, x plus 3. Like, that's legit. The x plus 6 is not, because I can't just roll that other 2 in there and make it 2. It would be 2x plus 6, not x plus 6. And we can see... There's no way to get x plus 3, x plus 6. Yeah. 2x minus 10, 2x plus 6. Like, this should work. 4x squared, 12x minus 20x is negative 8x. Negative 10 times is negative 60. Yeah, so it brings us back here. So anyways, 1 is the only answer. I mean, it's definitely a factor. Yeah, can't be neither. I mean, it could be neither, but that one's definitely right, so... 14, the given system of equations, k and t are constants. Infinitely many. Okay, what does that mean to be infinitely many? It means the two are exactly the same. So I put this one slope-intercept form. Y equals 3 over kx plus 1 over k. That means this must have the same slope and y-intercept. So let's isolate the y. Let's bring the 5y over, minusing it, and that's 3y is equal to, and then let's minus t to the other side, 3x minus t, right? Then we divide everything by 3, and we get y equals x minus t over 3. Okay. So that means that these two have to match up, the slopes have to match up. So 3 over k must equal 1, which means k equals 3. And then these two have to match up. Wait, that's a t and 1. Oh, and I already know k. So it's 1. K is 1/3. So that means t is 1. And that means k plus t is 4. Uh-oh. That's bad. Wait. I made a mistake. See, we have to be careful here. So infinitely many solutions. 3y equals 3x minus t. Y equals x minus t over 3. That's right. 3 over k. And then these two must be the same. So k is 3 because it has to match up there. T is, it's negative 1 because this is the minus and this is plus. Excuse me. So it's negative 1. So 3 plus negative 1 is 2. Good thing they didn't have 4. I would have been in trouble. Anyways, and then we can test it if we have. Do we have time? Nah, but we'll flag it. Maybe we'll come back if we have time. I don't want to risk it. Okay, what is the negative solution to the given equation? All right, negative solution. I mean, we can just plug and chug. So we got, and I could also graph this. Here, let's use the calculator a little bit more. I'm gonna show you how to do it. Okay, so all you have to do is say 3 plus absolute value 10 to x. Absolute value plus 3 times absolute value 5 plus x, absolute value is equal to 45. Oh, wait, no. Let's say it's equal to y. And then we'll say y is equal to 45. So then we'll get, it'll intersect. Okay, so there's my absolute value. Boom. So we got two solutions. We got one at 0 and one at -10. And that's pretty much it. But we're going to double check it anyways. So -10 would be 10 plus -20 is -10. Absolute value is 10, and that's 30. And then that would be 3 times 5 is 15. 30 plus 15 is 45. Boom, done. Yay. 16. A baker allocates 1,200 to buying. Baker must buy a minimum of 85 units of ingredient to receive a discount. And you got $1,200. The baker pays $6.20 per unit of flour. Let's say flour is X. And $14.70 for sugar. What is the maximum number of sugar units the baker can purchase within the budget? Oh, I know what this is. Okay. So we have to get 85 minimum. Okay, we're going to need to use a calculator here. So what is the maximum number of sugar units? Okay, let's start at the top. Let's start with 85. So 85 times 1470. We have to fit within this budget. 85 times 1470. It's too much. It's beyond the budget of 1,200. I figured that was going to be too much, but okay, so that's out because that goes over the budget. Now let's go to 80. And how many units do we need? 85. So we need 85 in total. So if I get 80 of the sugar, right, I'm going to have to get 5 of the flour. I bet you it's too big. So 80 now. And then plus, and then we need to say plus 5 times 620. Too big. B is out, right? It goes beyond 1,200. So it's probably 79. That's my guess. Now let's see 79. But if it's 79, I have to get 6 units of this. Hey, it works, just under 1,200. So B is the winner. I'm sure 70 will work. But again, it said, what is the maximum number of sugar units? Okay, great. The function H, blah, blah, blah. The value of the card decreases by R% of its value the preceding year. What is the value of R? So here's the dealio, right? We look at this exponential function, and it's decreasing exponentially. And the amount it's decreasing by is whatever this is less than 1. It's 0.2 less than 1. That equates to 20%, right? And again, think about it this way. It's 80%. If you're keeping 80%, what are you losing? 20%. So A is the winner, 20, boom, done. 18, the function P is defined by blah, 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 blah. Which of the following equations defines the function Q? Wait, hold on. Okay. So Q of X is P of 3X. So what you're doing is you're taking P and you're plugging in 3X for X. So 3 to the 3X. So this would be Q. I'm sure it's not. Yeah, they didn't put it in that format. But it's B. I'm going to show you why. So, and by the way, you can put this into Desmos and then put in all of these and see which one, as long as you know this, and see which one overlaps with it. But I'll show you why it's the same. This is the same as 5 times 3 to the third times 3 to the X. Oh, sorry. 3 to the third, that's what I mean, to the X, like that. Because you can strip away, remember, exponent rules say we multiply that back in with the floating exponent. So 3 to the third is 27. So that's why it's B. Let me just make sure I didn't make a mistake. Yep, I feel good about it. All right, 19. We got to hustle. One solution to the given equation can be written as blah, blah, blah. All right, so as soon as I see a nice little radical there, that tells me we got to use quadratic formula. So let's do that. Negative B, so A, B, C, negative B is -4 plus or minus square root of B squared, which is 4 squared, which is 16 minus 4 times A, which is 1 in front of the X squared, times C, which is -13, all over 2A, which is 2 times 1. Okay. And now we got negative, that's going to cancel out. 4 times 13 is 52 plus 16 is 68, right? 68. -4 plus or minus over 2. 68 is 4 times 17, so that comes out as a 2, so it's 2 rad 17. So -4 plus or minus 2 rad 17 over 2. And then we can divide everything by 2. Then we get -2 plus rad 17. Rad 17. And this matches up beautifully with that. It should be plus or minus, but they just want the positive one. Doesn't matter. But K is what's underneath the radical. K is 17. That's how you do it. Boom, done. Okay. Next, in the given equation, B is an integer constant. If the equation has exactly one real solution, what is the least possible value of B? Okay. So let's distribute. First, we got 9z squared plus bz plus 64. I added 64 to both sides equals 0. Why did I do that? Because when we see a quadratic, which this is, which we see when we distribute the z, when I see a quadratic, it says exactly one real solution, I'm thinking discriminant. That's it. The discriminant is, if this is A, B, and C, b squared minus 4 times a, which is 9 times c, which is 64. And when we say exactly one real solution, the discriminant must equal 0. All right, so now we want it's weird that they say least possible value because there should be an exact value for b to have exactly one solution. But anyways, whatever. So then 4 times 9 is 36. Hold on. 4 times 9 is 36 times 64. And it's that minus 2304 has to equal 0. So b squared is, we add it, is 2304. I wonder, it must be a perfect square, right? Then we have to take the square root of that. 2304. 48. Boom. So we'll say 48. And now we can check it. We can say if this was 48. Oh, and you know what? The other thing is, if it is 48, it should be a perfect square because that's how you know it is one solution. Let's do it that way. Let's just assume it is 3z, and then there would be 8 and 8. Yep, see, it works. Look, 24, 24, 48. All right. 2 left. 21 and 22. Let's go. Tutor charges. Tutor like me. All right. Tutor charges $90 for the first hour of tutoring plus an hourly fee for each additional hour. So 90 plus something per hour after. Oh, for each additional hour. So it's like X minus 1. So that, you know, because that first hour is $90 times something, times some fee. But I don't. Oh. And then let's call that, let's call that rate like R. Okay, so here's my equation. 90 plus X minus 1 times whatever my rate is equals the total cost, okay? Or total, we'll say H, whatever. I don't know why they say H because that reminds me of hours, but it is what it is. So we know that when you have 5 hours of tutoring, meaning X is 5, so that's 90 plus 4R, this equals $370. So now I can solve for R, and then we can bring it back there. So minus 90, 370 minus 90 is 280, right? 280 equals 4R, so you divide by 4. So the rate thereafter is $70 per hour. And that means we can replace that with 70, and then we can simplify. So it's got to be A or B, because those are the ones that have 70x. And let's see. Oh, I mean, you could just plug in 5 also, too, now between these two. So if I plug in 5 here, I get 350 minus 20 is 330. Plug in 5 here, 350 plus 20 is 370. So it's got to be this one. But anyways, if you simplify this, you get 70x minus 70 plus 90. So it's 70x plus 20. B is the winner. Done. Let me make sure I didn't make a mistake. Yeah, I think it's right. Okay. Last one, we got a nice 11 minutes, so we should be good to go now. I can kind of take a breath a little bit. Okay. All right, so we got 2 data sets, blah, 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 frequency tables. Okay, 2 data sets of 20 integers summarized in the histogram. For each of the histogram, the first interval represents frequency of integers greater than or equal to 10. Oh, right. But less than 20. So 10 to everything up to 20. Then this is 20, everything up to 30, blah, blah, blah. Okay. They're just explaining it. What is the largest possible... these questions are difficult. There was one like this on an old school SAT. I remember I really had to think about it. I got it wrong, as I remember, but then I figured it out eventually. Okay. Yeah, this is from one of the digital SAT practice tests. Well, I got a good 10 minutes, so hopefully I'll be able to crack it. So what is the largest possible difference between the median of data set A and data set B? Now, so we got 20 integers, right? Oh, no. This is easier than that one. Never mind. I just realized why. Okay, so we got 20 in each, right? So what is the median of 20 integers? It is the 10th and 11th value averaged, okay? The 10th and 11th value average, because we have an even number, so you have to take the mean of the middle two. The best way to think about it is if you have 10, you have 1 through 9, 9 on the left. 11, you have 12 through 20, 9 on the right, so you know those are the middle. Okay, so where are the 10th and 11th values? So I've got 8 values, and then I got 6 values here. So my 10th and 11th value are going to be in here, okay? And for data set B, I've got 8, same thing. My 10th and 11th value are going to be in here. And so we want the largest possible difference between the median of A and B. Okay, so that means I want the median of B to be as big as possible and the median of A to be as small as possible. All right, so A, does it say unique or no? Let me see. Integers. It doesn't say they're different. Okay, it doesn't say they're different. So I can say that the median, I could say that this is all, let's make the median of A as small as possible. So let's say they're all 11, okay? All of these are 11. So the average of 11 and 11 is 11. And then let's max this out as much as possible. Let's pretend everything in here is 40. I'm trying to get the biggest difference, right? So if they're all 40, because this one is, I think it said it's greater than 30, but up to 40, right? Oh, no. The first interval represents greater than or equal to 10, but less. I'm sorry, I did that wrong. So, sorry, this one is 10. This one is, oh my God, I totally did that wrong. I said 11. It should be 20 through 30, but it can be as low as 20. So we can say the median of this one is 20. All right, sorry about these mistakes, guys. And then this one can go up to, but not including 40. And since it's integers, the biggest it can be is 39. So, because we could have all 39s in this group and all 20s here. So then a median of 39, a median of 20, and the difference would be 19. And there we go. Oh, all right. It wasn't as bad. I just messed up a little bit. All right. Let's go back to the one. I think I flagged something, right? Where was it? It's this one. Look how nice that is. Okay, so what was I going to show? Oh, yeah. I was going to show you that K and T, you can prove that, I think it was K was negative. No, K was 3. I think we said, and we said T was -1. And those two add together is 2. I can prove it to you, so watch. This is the great thing about the calculator. So we want infinite solutions, meaning they have to overlap completely. So we can say the first one, look, 3x plus 5y equals 8y. And then plus t, so we said t is -1, so there we go. And then the second one, k is 3, so 3y equals 3x. So now if we zoom out, look, they're the same. You see? Well, here, you can see if I move one and they match up. So anyways, that's a nice little verification once you know those values. All right. Let me just see how we're doing. Yeah, we're good. Okay, I'm going to go ahead and submit it. And if we made any mistakes, we'll check them and review and see what happened. Otherwise, let's check it out. We'll take some questions. Oh, what the heck? 770. I must have made a bunch of mistakes. What a dagger. I thought I got everything right. I really did. Okay, let's take a look. 770. So we got all those wrong, obviously. Didn't do the English. So weird. I felt pretty confident there. Okay, let's see. Are you kidding? I got 18 wrong in the first module? How did I get this wrong? So let's see the right answer. It was 9.4, which is what I had the first time, but then I changed it. So what did I do wrong? I really thought I did this right. Wait a minute. Hold on a second. Okay, let's see. So here, let's get 2 points again. Let's do it one more time. So I said my points were 10 and 19. Use the same points. 10, 19, right? And then let's use this one, 24, 32. Okay. 32. So get the slope. 32 minus 19 is 13, right? And then 24 minus 10 is 14. So the slope is 13/14. And then in point slope, y minus 19 equals 13 over 14 times x minus 10. And then we want the y-intercept, right? So that's 130 over 14 when you distribute that. Boom, boom. And then you add 19. Okay, let's try it again. You add 19. Dang it. It is 9.7. What did I do? How did I get the 4.7? I don't remember how I must have messed that up. I don't know what I did. Maybe if you guys tell me. I thought I did exactly that process. Let me see. I'm doing icy, but we are simplifying. Yeah. So I don't know what I did. I apologize. I should have definitely gotten that one right. I don't know. And I had it, but then I switched it. I don't know. I don't remember what I did. But that's the same process. You should still find 2 points, get the equation, all that stuff. And the reason why you have to do the 2 points is like, you might be like, oh, it's right about to hit the axis. So you might choose 15.3. But again, this is at 10, 12. This is not 0. This is 8. So anyways. Well, that was terrible. Okay, let's go to the next module. See what I got wrong here. Oh my God, I got 2 questions wrong. It's ridiculous. All right, so let's see. Oh no, I already know what I did wrong. I rushed. I totally rushed. Okay, I'm going to show you what I did wrong. I get it. You see this? Represents the value in dollars of a car after X months of use. I gotta pay. So that's one thing I'm noticing on the digital. And there's more of these little tricks that you gotta watch out for. So I'm so used to not expecting those tricks that I just blast through it, right? So it got me. It's good. It's good. All right. So anyways, after X months of use, value of the car decreases. So if the value of the car decreases each year by R% of the preceding year, okay? So we have to figure this out, right? What do I plug in for X to get years? Well, so in months, that'd be 12. So it's 12,000 times 0.8 to the 12 over 4, which is 3. Okay. So what you can do then is you can basically take 0.8 and cube it, right? And what is it? It's 51.2%. So that basically is like this, 0.512%. Well, if you have 51.2% remaining, what have you dropped? 48.8%, right? It's whatever is 100 minus that, and then turn into a percentage. So it's definitely C. Oh my God. All right. So that's good. Good lesson for you and me, both of you guys. Okay. Both of us, all of us. And 20. What? How was that wrong? How could that be wrong? One real solution, the discriminant is 0. Okay, hold on. 9z squared plus bz plus 64. So b squared minus 4a. I don't know. See what they said. Oh, so sneaky. Negative 48. Because it was plus or minus 48. Oh, that's so crazy. That's so crazy. Okay, well, that's a good one. Good, very good trick. Very good trick. I didn't even think about the negative side. So that's why they said least possible value, because I was like, what do they mean? Like, it should just be a single thing. Of course, the plus or minus. So these are all what I like to call good mistakes, because like even when my students are prepping and we're kind of learning the new digital SAT, they're learning mistakes. They're teaching you. They're giving you reminders. So hey, it is what it is. And yeah, that's what I do. Just keep taking practice tests, keep getting better and better for you guys. Okay, that is it, guys. thank you so much for joining. If you could give this video a like, we'd really appreciate it. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Last but not least, if you haven't done so yet and you want more practice materials, once again, the SAT crash course in the description link below. Use the code SCALAR for 20% off. It's pretty legend. We're going to be the best, us together. Okay, it's a great team, great partnership, and we're going to get you ready, so take advantage. All right, guys? Thank you guys so much for joining, and I'll see you in the next